linear equality, right? But today we are going to be dealing with inequalities. Now, it is a deviation, right? But it is still necessary. My name is Nathaniel, and in this video, I'm going to be dealing with linear equalities, linear inequalities, and linear programming. And pay attention carefully so that you can be able to polish your knowledge in mathematics for inequalities. Now, moving on, the first part we'll be dealing with in inequalities is we'll be dealing with number lines, because number lines are basically where inequalities stem up from. So number lines, but before that, let's talk about whether something is equal to or not equal to something. Now, if I say my height is 175 centimeters, now that is an equals to, because if height is h is equals to 175 centimeters. Yeah. Now, but if I say my height is greater than 175 centimeters, so that means that is no longer an equals to sign. It's no longer an equation. This was an equation. Height equals 175 centimeters. That is an equation of my height. Now, but if I say my height is greater than 175 centimeters, that no longer becomes an equation. It becomes an inequality. So we'll say my height is, instead of equals to, we make it of greater than sign, and it is the sign, the shape made by the right hand when we raise it, when we curve it like this. So this is the right hand, and we make it of this greater than sign. It points in the right, greater than 175 centimeters. So there's a difference. This first statement means that the height is equal to 175 centimeters, and this second statement means that the height is greater than 175 centimeters. So if I wanted to say my height is either greater than or equals to 175 centimeters, we will represent it as height is greater than or equals to 175 centimeters. Now, and so on and so forth. If we were talking about lesser than, if the height is lesser than or equals to 175, I would use height is lesser than or equals to 175 centimeters. So these are the various symbols and notations we would use in linear inequalities. You make use of the greater than symbol, we make use of the lesser than symbol, we make use of the greater than or equals to like this, then we make use of the lesser than or equals to like this. Now these are the various notations, and now let's delve into what inequalities involve. Now, inequalities, you solve them just equations, but instead of having a definite region, they have just a diffuse region of points. Now, for example, let me give this example. Find the range of values of x for which 5x minus 4 is greater than 11. So we have 5x minus 4 is greater than 11 in this question. So we are looking for the range of values for which 5x minus 4 is greater than 11. So we are to show the result on the number line. So the first thing you are going to do is you are going to pretend that this is an equation. That's the first thing, and that's the greatest thing you have to do. Just pretend that this is an equation, and I assure you that's the most difficult thing. But once you've pretended that this is an equation, then inequalities are extremely easy. They're even easier than equations if you look at them from a graphical perspective. Now, let's say 5x minus 4 is greater than 11. So 5x is greater than let's move this let's add 4 to both sides. That will be 5x is greater than 11 plus 4. So 5x is greater than, on the right hand side we have the summation, so that gives 15. That will give 15. 5x is greater than 15. Now, just as if it's an equation, just pretend it's an equals to sign. So what's the next step to take? We divide both sides by the coefficient of x, which is 5. So that would be x is, I'm even about to make a mistake of equals. So x is greater than 3. So that means x is greater than 3 in this inequality. So that means this is our inequality. It means that x, whatever x is, x would be a height, x could be a quantity. Whatever x is greater than 3. So if we say x is greater than 3, x could be 4. It doesn't matter. X could be infinity. But as long as x is greater than 3, it satisfies our inequality. Now the next stage of this question is you have to represent this question in this result rather in a number line. So basically, a number line, which I've talked about earlier, is basically an arrangement of numbers on the left and right hand side of the negative 0. Of the neutral 0. So the negative numbers will be -1, -2, -3, and then our positive numbers will be 1, 2, 3, 4. So now we said x is greater than 3, right? So that means we'll have a notch here. We'll have a notch here, and then we'll make the arrow point in the direction of this greater than. The greater than is pointing in the right hand, so our arrow will point in the right hand, and then we'll draw the arrow. So this is how to represent it in a number line. So those of you who are familiar with number line, you will still get this, and those of you who are not familiar, you can still understand that this is what I'm trying to say. So you put it, since x is greater than 3, you just put your notch on 3 and then point in the right hand direction, because right hand means greater than. So what you mean is x is greater than 3. That's simple. But then if you for example, let's just make this messier. Let's make it more expanded. So for example, what if we are talking about x is greater than or equals to 3? So that means x is greater than or equals to 3. So just assume, just change our questions now. So instead of having this notch, we will still have this notch rather, but then we will shade the space inside the circle. So that would be, we will shade it up. So if you have only a greater than, you will not shade the space inside that notch. But if you have greater than or equals to, you shade the space inside the notch. Even if it's lesser than or equals to. For this symbol now, so who can tell me what this means? So if I have my notch on 1 and I have it in the left direction, so that means this is a lesser than. See, because it's in the left direction, is lesser than. So that means, and then the notch is not circled. So that means x is lesser than 1. But if I have this notch shaded, that will be x is lesser than or equals to 1. So that's the difference between a shaded notch and an unshaded notch. Very simple concept. You won't have any problem with it. Now, I want to explain the basics and rudiments. Let's jump into some examples before we go to linear programming, not computer programming. Now, linear programming, just we've not gotten there yet. Now, let's deal with this. Given that x is an integer, find the 3 greatest values of x which satisfy the inequality 7x plus 13 is lesser than 2x. So let me clean board and then let's deal with this question squarely. So now we have a question here stating that if if x is an integer, so and you remember that integers are positive or negative values. They are just your numbers ranging from your negative to your positive, and those are your number lines. The digits are on your number line. So now 7x plus 13 is lesser than 2x. Now this is an inequality, and once again we are going to pretend it's an equation and we'll just solve it just like an equation. So the first step, just like an equation, is to collect the like terms, right? So that means 7x minus 2x. Then we'll move the constant to the right hand side, is lesser than minus 13. So then we have 7x minus 2x is 5x lesser than minus 13. So then we have let's divide both sides by the coefficient of x, which is 5. So x is lesser than minus 13 over 5. So x is lesser than, let's change it to mixed fraction to make it more corporeal, to make it more easier for us to imagine. So now minus 13 over 5, that would be minus 2 whole number 3 over 5. So now in this it is more imaginable now. It's easier for us to relate to it, because now we know that instead of writing minus 13 over 5, we have it now that this is simply minus 2 with a fraction of 3 over 5. So this is what we'll be using for our number line. So now let's go on, but without using a number line first, the question doesn't require a number line. It just said we should find the 3 greatest values of x which satisfy the inequality. But personally, I want this to be very easy for you to understand, so I will make use of a number line now. So for example, if we have a number line and then this is minus 2, this is minus 1, and this is 0, and this is minus 3, this is minus 4. Now we'll locate this value. So minus 2 over 3 over 5, that's minus 2 with a value of 3 over 5. So if we divide this space between minus 2 and minus 3 into 5, so we'll have 3 parts out of that 5 spaces. So let's just approximate it to this space, random space. Now x is lesser, so that means this will be the arrow will be in this direction, lesser than minus 2 whole 3 over 5. So this is how to represent it in number line. Now, but that's not where we are headed. Now what we need now is we just need these 3 greatest values of x. Now the 3 greatest value of x will be the values that are just after this notch. So we can say this will be minus 3, minus 4, minus 5. So the reason why we are using whole numbers is that this question says x is an integer. An integer is a whole number which is either negative or positive or neutral, which is 0. Now, so we can if we're just given an ordinary x, we would have infinity as the answer, because there are an infinite value of numbers between this notch and these digits. So for those of you who are a little bit keen and apt in mathematics, you would be able to understand what I'm saying. But for those of you who are just beginning, it's okay. So let me just not just delve into complex matters. Let's just be satisfied with our answer. So the three greatest values is -3, -4, and -5, which are directly after the notch, this notch, -3, -4, and beyond -4, -5. Now this was an inequality with one variable. Now some questions also involve two variables. So what can we do in face of such questions? So I'm going to be dealing with such questions, an example of that, and then I'll also be representing it on a number line. So this question says, show on a graph the region that contains the set of points for which 2x plus y is lesser than 3. So we have the 2x plus y lesser than 3. So what we are looking for is just the region that satisfies this inequality. So now, once again, we are going to pretend that this is an equation, and this time around, we are going to actually put the equality sign. That's a cheat, right? It's a big cheat, but we are going to pretend. Now, let's assume 2x plus y is equal to 3. So the reason for that, we are looking for a definite region from which to perform our operations. Now, we are going to test the origins. We are going to look for the intercepts, rather. So we are going to look for the intercept. So the x-intercept is at y is 0. So that means 2x plus 0 equals 3. So this is the x-intercept. So 2x equals 3 and x equals 3 over 2. So the x-intercept was 3 over 2, 0. So that's the point we are looking for, x-intercept. Now let's look for the y-intercept. So y-intercept is gotten when x is 0. That means 2x plus y equals 3. That means 0 plus y equals 3. Or rather, y equals 3. So that means the y-intercept is 0, 3. Now if we have an imaginary Cartesian plane, here we can represent this, because we have to show it on a graph, right? The region which contains this point. So the first thing you do is you just map out your intercept. You just sketch your intercept. Now if we have x as 1, 2, and then we have y as 1, 2, we don't need much. So now x is 3 over 2, that's 1.5. So that will be between 1 and 2. That's the x-intercept. Then the y-intercept is 3. So let's extend this and have an imaginary point of 3. Now when you connect these intercepts, you will get the line, this line. So this line is the graph of the inequality of the equation 2x plus y equals 3. Now for you to convert this equation, because this line represents the solution of an equation, to convert the solution of an equation into the solution of an inequality, we have to test the origin. So that is the step that takes inequalities a step ahead from equation. So how to test the origin? You just assume that both x and y are 0. So if x and y are 0, that means 2x plus y equals to 3. That means 0 equals 3. So both x and y are 0. We are testing the origin. So now we are going to remove that equality sign and replace it with the original sign of the equation, which is lesser than. So it's 0 lesser than 3. So if this is an equality and we are going to query it, because we are going to verify whether it's true or not. Is 0 lesser than 3? Now if it is true, if when testing the origin you get a true value, then you are going to that region that contains the origin will be shaded, and that will be the region that satisfies the inequality. So we can see that 0 lesser than 3 is true, because 0 is actually lesser than 3. So that means this region that contains the inequality, this region that contains the origin, that's this region. Let's call it region A, and let's call this region B. So this region A satisfies the equation. So this region that contains the inequality, we are going to satisfy the we are going to have it like as this. But now I'm making a little bit of mistake here, because now we have our sign as lesser than. So that means it won't involve this line. So we won't have a solid line. We'll just have a dashed line, because this line is not part of the region. So, but if it was lesser than or equals to, we will have a solid line. But since it's not lesser than or equals to, this region is not part of it. It's only this region below it. So this line is not part of it. So this is the region A, which contains the origin and which satisfies inequality. So I guess that does it. And moving on, we have that. So next, let's go on to linear programming. So linear programming. Now, linear programming is just a real-life application of inequalities, and where we make use of the regions and all the rest and spaces. So we just make use of real-life applications of of inequalities in business, in commerce. In businesses and commerce, there are always these real life applications, and these real life applications, they are evident in our compromise. In life, you have to make a compromise, because whenever you try to offset a factor for another one, that factor will also be affected. So it's just like you have to balance everything. So, and this inequality, the concept of inequality, coincidentally it kind of resonates with the concept of balance in the real life. So that means if you are going to balance something, you are going to have an inequality. So because if you are going to balance something, you have to have an inequality first that you are attempting to equalize. So that is where the concept of linear programming comes in. And the meaning of all this jargon I have been saying since is just that linear programming is the branch of inequality that is applied in real life. So now, this linear programming is as bogus as it sounds. It's actually the easiest part. So we are just going to deal with a question here, and then you'll be able to understand why I said it's easy. So now in linear programming, we have a particular question here. We have a student has 500 naira, and in case you are not in Nigeria, the naira is the currency of Nigeria here. Now she buys pencils at 50 naira each and erasers at 20 naira each. So you could just replace that naira with any currency you feel like. You could call it $20, whatever. So, but in mathematics, we don't care about currency. Mathematics mathematicians are not economists, so we are currency blind. Now we have she has 500 naira. She buys a pencil at 15 naira each and erasers at 20 naira each. She gets at least 5 of each, and the money spent on pencil is over 100 naira more than that spent on erasers. Find how many ways the money can be spent. Find the greatest number of pencils that can be bought and the greatest number of erasers that can be bought. Now she buys X pencils. Let's say she buys X pencils for 15 naira each. So X pencil for 15 naira each, that will be the total cost of pencil will be what? 50X. And then Y erasers for 20 naira each, that will be the total cost will be 20Y. So when we add the total cost, we are told that the total cost is will always be lesser than or equals to 500. The reason for that is that she has 500 on hand, so she can't spend more than 500. Is it that she spent 500 or she spent less than 500? So that in inequality we denote that as lesser than or equals to. That is why the total cost she will spend will be lesser than or equals to what she has. So that's why this is valid in inequality. Then let's move on next. We have they said she gets at least 5 of each. So that means she gets at least 5 of the pencils and 5 of the she gets at least 5 of each. Yes, that means X is greater than or equals to 5, which is the number of pencils, and then Y, which is the number of erasers, it will also be greater than or equals to 5. So that's what that statement means. So in linear programming, what you just be doing, you are going to be transforming every statement into an inequality. So when you said the number of pencils is greater than or equals to is at least 5, that means it can only be greater than or equals to 5. The number of erasers can also only be greater than or equal to 5. So I hope you understand what I'm trying to say here. And then we are told that the money spent on pencil is over 100 more than that spent on erasers. So now the money spent on pencil is over 100 more than that spent on erasers. So what we can infer from here is that if we represent this linearly, we have that means 5y. If it is over, that means it's at least 100 naira. It's at least the money spent on pencil will be at least 100 more than the money spent on erasers. So that means the money spent on eraser, which will be 20y, is it will be let's start with money spent on pencils. The money spent on pencils will be 50x, and this 50x, this is money spent on pencils. We are told that it is over 100 more than the money spent on erasers. So that means that would be greater than or equals to money spent on erasers, and over, not equals. So if they said over, that means it's strictly greater. So it's 50x will be greater than the money spent on erasers. That's 20y. Because it is greater than, we are making it a plus 10 plus 100 naira. So let's divide all through by 10. That's 5x is greater than 2y plus 10. So we can also, when we move the variables to the right hand side, we have 5x minus 2y is greater than 10. Now we have different regions. We have region 1, this region here, we have the second region, we have the third region, and then we have this region above. So if we divide the first region by totally, we have a region of 5x. If we divide by 10, we have 5x plus 2y is lesser than or equal to 50. That's the first region. So now the next step of this question is just to map out this region on a Cartesian plane, and then you are going to look for the intersection where for the region where these inequalities intersect, and that region will be the region that satisfies these inequalities. Now we have for the first one our intercept. For the first one, you can say when x is 0, our x-intercept for here will be when y is 0, 5x will be equals 50, and then x will be equals 10. That's 10, 0. Then our x-intercept will be when x is 0, so y equals 50, y equals 0, 25. So we have that as our x-intercept. Then that was for this equation here. Then for the second and the third, we don't have intercept because they are just x greater than or equals to 5. So they are simply lines on their own. Now then for the last one, what's the intercept? So when y is 0, x is 2, 0. Then we also have when for the y value, when x is 0, we have y is equals to minus 5. That's 0, minus 5. Now that's the intercept for this one. So now we can simply begin to plot the values. So now let's use a scale of 10, 20. Let's make it larger. Scale of 5, 10, 15, 20, 25, and 30. So now this one is, and on the x-axis, let's use a scale of 5 to 10. This one we have a scale of minus 5, minus 10. On the negative y, on the negative x, we have a scale of minus 5, minus 10. Now here, for the first intercept, we have 10, 0 and 0, 25. So this is 10, 0 on the x-intercept and 0, 25. So this will be our first so this will be our first line. So for the next one, we have for the next intercept, we have 2, 0 and 0, minus 5. So we have 2, 0, which will be positive x, and 0, minus 5, which is here. So we just draw the imaginary line. Yeah. And then for the remaining two inequalities, they are simply lines of the coordinate. So that means x is greater than or equals to 5. So that means it's simply represented by this line, x is greater than or equals to 5. So it's a solid line. So and it points in this right direction because x is greater than or equals to 5. So and then the other one, y is greater than or equals to 5. So it is this line which points upwards. That means y is greater than or equals to 5. So you can see that we are getting a region here, and this region we've gotten here. So for this one, if we test the origin for this region, we have 0 is lesser than or equals to 50. So that is true. So that means it contains this region. And then this last one, 0 is greater than or equals to 10. It is wrong. So it contains this upward upward region. So you can see that at the end of the day, they all intersect at this region here. So let me shade it here. So this will be the region satisfied by those group of inequalities. So and then this is simply the region satisfied. And then if we were to go further, we'll just make use of the points on the equations. Now what you just do is you are going to make use of the vertices of these equations. You just make use of the vertices. This first one, we have a point 5, 5. Yes, we have a 5, 5. In this point here upward here, we have a point of intersection between here and here. We have approximately let's call this will be approximately 7, 6. Then we also have an upper region. But if you evaluate this, you see that the region 7, 6 is the one that will allow us to allow the student to have the greatest number of pencils. So the greatest number of pencils is the vertices of this region that in which the pencil axis is greatest. So this is the this depends in this region. The pencil axis is greatest as in this point, and then if you are looking for the point which satisfies for the eraser to be greatest, you make use of the y, because the y axis is the eraser axis, and then the x axis is the pencil axis. So that is just how linear programming works. So today, I guess that as far as we can go in this video. Thank you for watching, and see you next episode.